Factoring simple trinomials. Well, they're simple, basically meaning that you don't have to do as much investigation into the factors of the numbers, because the leading term is going to be having a coefficient of 1. Same thing over here, coefficient of 1. It's called a simple trinomial. What it requires is that we're going to turn this into a multiplication. We have 3 terms, that means try, right? 3 terms. We're going to turn it into a multiplication with 2 brackets. And both of these brackets are going to be binomials, 2 terms. And it all hinges upon looking at the last term and its factors. And we're going to go through a process that takes us backwards through the trinomial twice, and we're going to ask different questions each time. The first time I go through and say, I need factors of 12 that are going to add to give 7. Don't pay attention to this minus sign yet. So the factors of 12 that add to give 7, well, there's 1 times 12, 2 times 6, or 3 times 4. And 3 times 4 is the pair that's going to work. And what you do is you take those 2 numbers and you're going to place them at the back of the bracket. These are the guys that are going to multiply to give the 12. Now the front of the bracket, because it's a 1, there's only going to be one way that could have broken up, and that's going to be x and x. We're halfway through the answer. The next time I go through and ask the questions, I have to, again, like I said, the second time through, from the back, I need to find, I have my 3 and my 4, I need to find the signs that are going to go on here. Well, I look at this and I say, the sign is a plus, which means the multiplication is either a plus times a plus or a minus times a minus. So the signs must be the same if this is a plus on the last term. And the larger of the 2 numbers, well, they're the same anyways, but the larger of the 2 numbers is going to be negative. So they're the same, and the larger is a negative, well then the other one must also be a negative. And there is your product of 2 binomials that would give you that back. Double check, is x times x equal to x squared? Yeah. Is negative 3 times negative 4 going to give you positive 12? Yeah. And is negative 3x and negative 4x going to add together? These 2 products are going to form 2 terms, negative 3x and negative 4x, and they're going to add together to give the middle term, negative 7x. I can do the next one a little bit faster, but I'll tell you right now, the fact that this last term is negative makes it a little bit more difficult. So the first set of questions I'm taking, and I can actually start setting it up right away, and I'm taking the A's for the front, and I need to look at the 24, and I say, are there factors of 24 that are going to subtract to give a 5? Well, the factors of 24, 1 times 24, 2 times 12, 3 times 8, 3 times 8. You see why it's important to remember your times tables. 3 times 8, these are the values that multiply to give 24, and the 3 and the 8 will subtract to give 5. So I'm going to put those numbers into my bracket. Second time through now, I have to ask a couple of questions about the signs. This is, as I said, a little more complicated when the last term is negative. The last term is negative, so that means the signs that I'm going to have are different, because the 3 times the 8 is going to give a negative 24. One of them must be negative. So the signs are different or opposite, and the bigger one is going to be positive. Alright? So when we add them together, the bigger one's going to be taking the sign, right? Adding the signs, you have to remember your integer rules for this. So the signs are different and the bigger one's positive. So 8 gets the positive, 3 must get the negative. And you can FOIL this out to make sure that it in fact does give you the right answer. So it always comes down to that last term, okay, factors of the last term. The sign on that last term tells you whether you're going to add or not. And, oh yeah, you could check, okay, for this one. And then you have to figure out what signs go on each factor to see what the final answer is. So I'll give you a third problem to work on. Let's choose a different letter. I'm trying to vary up the letters a lot. So let's say v squared minus 19v plus, all right, so already you know it's going to be a little bit easier. And when I make these up, I think of the values. Let's say 70. And you need the factors of 70 that are going to add to give 19. Well, if you could see inside my head, you would know that I was thinking of those factors when I started. And then you're going to turn this into a multiplication of two terms, and the signs are going to be the same. That's enough for now.